Hello, everybody. Welcome to this session on the best practices to migrate your Postgres and MySQL databases to Azure. My name is Sunil Agarwal. I'm the program manager leading the Postgres team here at Azure. And with me, I have Arun, who leads the tools team. The agenda for this presentation is a motivation why you want to move your Postgres and MySQL to Azure. And then Arun will walk you through how you migrate the MySQL and the Postgres using the tools we have to Azure. And finally, we will also put some focus on Oracle to Postgres migration, which is picking up speed with many of our customers. And you will see the rationale in the upcoming slides. So why migrate to Azure? Azure is a very compelling platform to host your open source databases. And the key reason is we host the community version of Postgres and MySQL with no vendor lock-in. You can easily migrate your database from wherever it is running onto Azure as long as it complies with the open source supported functionality and the capabilities. Azure brings with it over 30 years of experience of running enterprise workloads on databases, starting with SQL Server. So you can be rest assured your open source databases are resilient and stable that is needed by your enterprise workloads. And finally, Azure provides a very rich set of infrastructure to host your databases. So if you look at what that rich infrastructure is, first of all, like any public cloud, it is fully managed database. So you don't have to worry about hosting it. You don't have to worry about upgrading it. You don't have to worry about anything. It is just a database as a service that lets you focus on your applications rather than on the database. In Azure, databases are highly scalable. You can scale up and down online. And in case of Postgres, you can even scale out. You can have scale up as well as scale out. And these databases are running on the strongest secured platform that Azure is. Azure Public Cloud is the most secure platform, industry leading, and it has host of compliance certificates. So any kind of workload, you can be rest assured it will fit on the Azure Public Cloud. And finally, your databases have built-in intelligence. It can monitor your workload. It can help you understand if you're missing any indexes or how expensive queries are running. You can do a lot of those things inbuilt into the platform. And this allows your DBAs to not worry about as much about tuning your application and then keep a focus on the architecture of the application. And finally, these databases are integrated in a very rich Azure ecosystem. So, for example, you have a built-in Power BI capabilities where you can make um, analytics of your data that is running your transactional workload. You can have a very strong authentication using Azure Active Directory with multi-factor authentication or password expiry. It gives you a sort of a single place to manage your authentication across Azure services. Similarly, you have Azure Data Factory, which allows you to ingest data and in an efficient way. And finally, you have app services and Kubernetes where you can have very rich implementation of your applications on Azure. So this whole combination is what Azure gives you as a platform. So we believe it's a very compelling platform for you to think about. Now, let's step back. Let's go back in time. How people had deployed the applications on premise. So if you look at this picture on the left side, you see a presentation layer, which could be the web client, or it could be custom UI, or it could be any other client, right? But it interacts with a application tier that is front-ended by a load balancer, right? And you can have an application tier that could be running on a web server or whatever, and it could be scaled out horizontally. It could be like a stateless application tier. And behind the scene, these application tier could be talking to the data tier. So this is like a three sort of a tier architecture that is very standard in the industry for a long time. And if you think about, there is nothing wrong with this architecture, right? People have been very successful in this architecture. But if you look at the challenges, though those challenges have been solved, but those challenges are that you as an organization are responsible to have your own data center, right? And you need to buy hardware, and you need to make sure that hardware is, kept up to date with the technology, right? So you own that cost. You are responsible for upgrading the database. Let's focus on the database. You're responsible to make sure your databases are upgraded, all the patches applied at a regular cadence, right? You're responsible for backups or HADR, high availability, disaster, all those things. Security, you need to make sure the database is secure. I mean, these days the vulnerabilities are uh, commonly exploited by many of the people with the bad intentions. So you want to make sure your database is fully secure, and you need to monitor, troubleshoot, and finally you have to manage at scale. I mean, it's not just one application that you're deploying. You could be deploying many applications. So how do you scale this architecture? And finally, how do you scale the application? So all those things, as I said, have been solved problems, but they are solved at the expense of the extra money and the resources and the expertise that you need to hire to host these things. Now, as a first step in this journey to Azure, the simplest way you can do is you can sort of move away from hosting your application and data tiers into your own data center. You can choose to move into a, a virtual machine on Azure as is. So if you look at the picture, the second picture, you use a tool called Azure Site Recovery. And what it can do is you can do a online migration from your on-premise infrastructure to the Azure VM. So here you're running load balancer, the application tier, and the data tier in a Azure virtual machine. And of course, your presentation layer remains as before. So in terms of challenges, the thing that you solve by doing this migration is you get rid of your data center or the hardware, right? Because with virtual machines, you can scale up and down based on the capacity requirement of your workload. And it is the responsibility of the Azure uh, cloud to make sure we are hosting your virtual machines on the latest and the greatest hardware available for you to run everything, right? Now, this is a stage one. Now, what happens is you want to go to the self-managed database, because in this time when you're moving your database to a VM, you are still responsible for the upgrades and the patches and the security and BCDR and everything else, right? So what you do, you use a database migration tool, which I show on the arrow at the bottom left, and that is the conversation of this presentation, that you migrate your data tier that is running on a virtual machine onto a PaaS service, which is Azure Database for Postgres and MySQL as a service. When you do that, everything else that we talked about in terms of the upgrades and the backups and everything is automatically taken care of by Azure, Postgres, PaaS, or MySQL. And you can continue to run your application on the app tier just like you were running before on the VM. So that's the step two. And finally, if you want to be more ambitious, you can eventually move your application tier from a VM and migrate that application to, say, microservices architecture. You can move it to Azure App Services or Kubernetes, and this becomes almost like your cloud native architecture That I'm not saying you jump to this cloud native architecture as a step one, but this is the phased approach that many of our customers have taken. So as I said, the focus of this talk is on this Azure. Let me just do the laser pointer here. We'll just focus on the database migration. Now let's move on. So the migration, again, we are focusing on migration of Postgres database and MySQL database. The migration can be homogeneous or it could be heterogeneous. Okay, homogeneous means that you are taking your Postgres engine that is running on premise. It could also be running on IaaS, right? And you migrate that to a Azure PaaS service. Interestingly, you can migrate from Postgres running on AWS or GCP, and you can migrate to Azure Postgres. And the same thing holds even for MySQL. Now, in terms of heterogeneous migration, as I said earlier, one of the things we are focusing on is to simplify migrating Oracle databases onto Azure Postgres PaaS service. Now, you may wonder why Azure is a good target for Oracle workloads. Well, there was a study done by a vendor. I'm going to show you the name of the vendor. And, and they sort of interviewed many people to understand why customers want to migrate from Oracle to Postgres. So the top triggering points are the digital transformation. As people are migrating from on-premise or virtual machines onto the cloud, they are rethinking about their overall infrastructure and the strategy. And as part of the digital transformation, they are gravitating towards open source technology. And of course, it goes without saying, cost is one important aspect of it. Like 51% of the people talk to say that cost was one of the key motivators to move out of Oracle. Similarly, I mean, they want to move to public cloud, right? Because they want to move away from the hosting it themselves. And a lot of organizations that we are seeing, they have standardized on open source for their new applications. And also, as part of that, they are bringing the legacy applications that are running on Oracle. It could even be other database vendors onto the open source platform, right? So there are some of the key motivations why customers are thinking about migrating from Oracle to Azure. And what we are seeing is many customers are uh, like saying to us, hey, there is an urgency to migrate because maybe their license is expiring, and they want to, instead of renewing the license on Oracle, they want to migrate to Postgres right away, right? And I think if you look at also the 86% of the respondents that they interviewed, in this case, the source is the Stratoscale annual Oracle to Postgres migration report. So what they said was 86%. I mean, that's a significant percentage. They want to migrate up to 25% of their Oracle databases to Postgres in the next 12 months, right? So as I said, we have a demand for homogeneous migration. We have a demand for heterogeneous migration from Oracle to Postgres. And now let's go into deep into how to achieve these things in more detail using the tools we have. And with that, I'll hand over to Arun to talk about it.
Well, thank you for that wonderful introduction, Sunil. Hi, everyone. It's great to be here today. By terms of introductions, my name is Arun. I'm a program manager with the Azure Open Source Databases team, and I lead the charter for migration tooling and helping our customers navigate the migration landscape into Azure Open Source Databases. Today, I'm going to talk to you about all of the things our team is doing in helping customers like you navigate the migrations landscape for migrating your workloads into open source databases on Azure. We have an array of demos. We also plan to show a few collateral that we've been working on to help make these multi-step migrations as predictable as possible. First up, let's take a quick look into the skeleton of migrations. We'll walk you through the different phases of a migration. We call them three main stages, and they are based off of the Cloud Adoption Framework, also known as CAF. We'll talk to you about some of the tools available out there in terms of migrating your data by itself. Our presentation today walks you through the entire workload migration by itself. And then once we are done with the explanation of the migration skeleton, we will walk you through migration specifically for three different variants that we are seeing our customers do a lot of migrations today, namely MySQL to MySQL, Postgres to Postgres, which are also called as homogeneous migrations, and also Oracle to Postgres migrations, which are also known as heterogeneous migrations. On the screen, you're looking at one of the first stages of a migration, which is also called the pre-migration phase. As I clearly called out, the cloud adoption framework lays out three different stages for a migration, namely pre-migration, migration, and post-migration. In the pre-migration phase, it concentrates on helping you plan, ensure all best practices are captured in one place for you to discover all potential workloads to be migrated to Azure, assess them, and plan your migrations. Given migrations are multi step hard projects to pull off, we are obsessing over getting you the right combination of tools, processes, and experts to navigate this space. In this phase, you could use the available discovery capabilities in Azure Migrate platform, use a combination of open source tools, documentation, and guides to look for fit in Azure Platform as a Service. You can then use your favorite open source schema migration tool to move your schema from the source to the target and prep an empty target database for migration. Schema migration tools include MySQL Workbench, MySQL Dump for MySQL migrations, and pgdump, pgrestore, and pgadmin for Postgres. We also have a Postgres extension in Azure Data Studio to help you easily navigate this landscape. The migration phase is where things get a little interesting. We have a bunch of tools catered to different scenarios for you to choose from, given you're trying to migrate into open source. You can use the native dump and restore tools that come with the database engine for MySQL and Postgres. You could also choose to use fast, parallel, thread-based offline migration tools such as MyDumper and MyLoader as well. The fact that our engines are 100% compatible with open source offering makes it easy and extensible to use these tools created by the community itself. Same goes for the native replication tools as well that we will dive deep and cover in later slides. Be it binlog replication for MySQL or logical replication via logical replication slots for Postgres, we have you covered from a migration and data integration use case point of view. Last but not the least, if you want some programmatic edge to your data movement challenges, we have the Azure Database Migration Service. DMS is a logical replication Swiss Army knife, helps with online migrations, and ensures peace of mind when it comes to migrating into Azure open source DBs. We will see a demo of the programmatic edge you get with this service when we walk you through Postgres to Postgres migrations. In short, once you choose the right tool for your migration, you have option to see through until the end, use the tool for your needs, and complete the migration project to get quick value out of the cloud. And lastly, the post-migration phase. Once the data movement part is complete, you enter one of the most important stages of the migration called post-migration. This phase ensures you're set up for success in the Azure ecosystem. Make sure you have taken care of items in all checklists across all subphases of the migration. It also ensures you have performed the required functional and performance tests in the interest of being successful in the cloud. Once all these steps are complete, you are ready to cut over your application to use the powerful, fully managed Azure open source database ecosystem. Here's a quick slide on the power of DMS. As stated earlier, DMS is a true Swiss Army knife being used by thousands of customers to migrate their data store workloads into multiple targets within the Azure data platform and not just open source databases. It is fully managed, easy to use with a few clicks, and enables repeatable migrations for for your migrations, not just for one time, but also multiple workloads in one go. Now that you have a good idea of what it takes to migrate end to end, let's dive deeper into migrating your workloads into Azure database for MySQL. Let's look at the entire CAF framework again. On the left hand side, where it comes to discovering and assessing your databases, connecting to Azure with your favorite schema migration tool and migrating the schema, that's part of the pre-migration phase. In the center of the screen, where you see the Azure Database Migration Service, which we are going to dive deeper into, that portion talks through to the data migration aspects. So let's take a quick look at the Azure DMS service. As we called it, it is a logical replication tool. It enables codable and repeatable migrations and helps you with continuous sync and keeps your target in full sync with the source until you're ready to cut over. So the way the Azure Database Migration Service works today is it consists of three migration phases. One, the initial load. Two, the apply cache changes phase. And three, the ongoing replications phase. During the initial load of the migration, the Azure Database Migration Service runs selects on all the tables that you need to migrate and pipes it to a comma delimited CSV file that gets compressed and stored in the Azure Database Migration Service instance. After that, we use the load data local in file command in MySQL to bulk load that data into the target Azure DB for MySQL instance. And while this happens, using row formatted bin logs, the Azure Database Migration Service spawns another thread to capture all ongoing changes from the source database and stores it in the DMS instance. Once the initial load is complete, it moves on to the second stage of applying all these cache changes in the target and brings the target in full sync with the source. At this point in time, we promise you that the target is fully consistent at a point in time compared to the source. Once that stage is complete, you are free to apply all referential integrity constraints, triggers, etc. And you're ready to move into the fully ongoing replication phase. Here, the DMS service captures all ongoing changes in the same manner it captured during the cache changes phase and gets the target in full sync with the source by applying them in the same order they occurred on the source in the interest of ACID compliance. Now, the database migration service, uh, as we called it, it's a logical replication tool. And the only downtime you're going to see is when you switch over your application, stop writes to the source, and switch over your application to the target. And we'll see a demo of how that happens with the migrations using the DMS service. And on the right, as we called it, this is the post migration phase, which we walked you through when we talked about the migration skeleton, where you go and do functional and performance tests, make sure everything looks good, continue to optimize, remediate your apps to ensure they can work well in the Azure ecosystem. And once you're ready to cut over, you cut over and start running your production database in Azure. The second option you have is data and replication or bin log replication. Given it's open source, uh, this is native to MySQL. And the way this works is there are Azure MySQL specific commands that you need to run after you do a dump and restore of the initial load of the database. You give it a bin log position and file name to start replicating from. And the capabilities within the MySQL database help you keep the target database in full sync with the source. And the third option is your plain old one-time load using dump and restore. MySQL dump is a single-threaded but operation, but it's proved to work really well. It can be run via the command line or even via MySQL Workbench. And we also, given its open source, other community-based parallel migration tools like MyDumper and MyLoader are also supported for fast offline migration. So if you can take an extended downtime just for the period of the migration, you could just choose to go with the one-time dump and restore option. and set the appropriate threads you want to parallelize, set compression flags, and other properties that we've cleanly documented based off of our experiences working with other customers to ensure loads into MySQL are really fast. And some of these properties include increasing the SKU size, increasing the disks for IOPS, and you could reduce the SKU after the migration is complete as well. You could disable indexes and recreate them later, and even toggle InnoDB parameters like IO capacity and thread parameters to ensure you're prepping the target in the right manner for fast migrations. You could also choose to use Azure Data Factory. Azure Data Factory lets you ingest all your data with built-in connectors. There is approximately 90 of them available today. It is easy to use, cost-effective, serverless, and you just get to pay for what you use. It is also powerful and can help with data movement for migration purposes into the Azure platform. Lastly, how do we ensure all the right best practices are followed? We talked about different tools. When do you use what? We launched the MySQL guide to help you make those decisions easily. You can access it in the GitHub link above. Migrations are solved by a combination of people, process, and technology. We wanted to bring in tools and advice on what experts bring in, plus the framework all in one place via the guide. We'll show it to you right after this demo. The guide also has a scenario based learning approach with labs that help you deploy a sample application to learn how to do the migration. It has all migration best practices, checklists per migration surface to ensure you do not miss out on anything important. Let's take a look at the guide.
This is the migration guide GitHub repository. As you can see, we give you access to ARM templates for you to set up your own workload to learn about migrating an existing MySQL workload into Azure database for MySQL along with the sample application. So you get a good flavor of what that migration looks like end to end. You also have the detailed migration guide. We'll go into how to use it and the best practices of following advice from the migration guide, and also a couple of appendices that help you set up the sample application and also walk you through some of the other important aspects for this particular migration. Let's take a look at the guide. So this is the detailed guide. It is 60 pages of content, walks you through different aspects of a migration, right from planning to schema migration to migration, post-migration testing, basically walking you through the entire setup of pre-migration, migration, and post-migration best practices that we've been talking about throughout this presentation. So if you look at this migration guide, it starts off with the planning aspects and the assessment aspects, gives you various details about what's going on from a migration point of view, and it also quickly walks you into a representative use case, making it very interesting for you to read this guide. We walk through a real-world scenario that we helped a customer migrate from an on-premises MySQL instance into Azure DB for MySQL throughout this guide, along with examples and scripts for you to understand different aspects of a migration, along with checklists to ensure you do not miss out on anything important. We also made this migration guide clickable. So basically, in case you knew where you wanted to go to, for example, let's say you wanted to understand different aspects of choosing the right migration tool for your data migration aspects, you could directly go into the decision table and look at different tools available out there, offline, online. Given this is open source, you get all of the advantages that come with these tools in order to help you choose the right tool for the right use case. So you have an option to choose offline versus online migration tools, what the prerequisites look like, what the advantages and disadvantages of each approach are. And once you're done with choosing the right migration tool, you could just move on to understand different aspects of the migration. Next up, in order for you to understand what it goes through, we've provided a sample conference demo application as part of that GitHub repository as well, where you go and deploy the ARM template and just follow all the instructions available in this appendices to be able to download artifacts, deploy the database, do the migration using a tool of your choice, and understand what it looks like from a migration point of view for migrating that particular MySQL workload into Azure database for MySQL.
Now that you know where the best practices are, let's take a look at a demo. We're going to migrate an RDS for MySQL database to Azure database for MySQL using the Azure Database Migration Service. Let's look at a migration from RDS for MySQL in the AWS portfolio to Azure database for MySQL. On the screen, you're looking at one of my RDS MySQL databases called Classic Models. And we've prepared a target Azure MySQL instance in with the same database with schema copied over. Next up, let's take a look at how you can use the Azure Database Migration Service to move this Classic Models database from the RDS MySQL instance to Azure DB for MySQL. Now that we've shown you what database we are trying to migrate from RDS for MySQL, let's take a look at the database migration service setup. You need to create the service, make sure the service has appropriate connectivity to your source and target, and then you go in and create a migration activity from the source, migrating that particular database to the target database that you're trying to migrate into. As you can see, DMS is a true Swiss Army knife. You can go from multiple sources to multiple targets. In fact, as you can see on the screen here, you could go from SQL Server to Azure SQL Database, SQL Virtual Machine, etc. In this demo, let's go into the Azure portal now. We'll talk to you about how to create the database migration service. So let's log in into the Azure portal. We can click on Create Resource. And just search for migration. As you can see, the Azure Database Migration Service pops up. Let's go in and create the service. The common scenarios are documented right there. You could choose an existing resource group you want to create the service in, or even switch out the subscriptions if need be. This all depends on what subscription and resources in a resource group have access to both your source and target database. For the purposes of this demo, I'm choosing DB readiness. We given a service name that you could remember by. Choose the appropriate location where you want to launch this service. And the service mode depends on the connectivity aspects of your source and target databases. If you have site-to-site connectivity, you could just create the database migration service in the cloud, use the Azure service mode option. If not, you could use the hybrid preview mode, which is supported for a set of source target pairs from a migration standpoint. For the purposes of this demo, I'm just choosing Azure service mode. You hit on configure tier. For large data sizes, you choose standard, and for online migrations with minimal downtime, you choose the premium SKU. It comes with 4 vCores, but do not worry. The service is free of cost for the first 6 months to help you migrate and navigate the migration space without any issues. Once you choose the right SKU, hit apply. You will then have an option to select an existing VNet or create a new one. The resources in this VNet and the particular resource group will need access to your source. And once done, you go in and create the service with the premium SKU option. For the purposes of this demo, we've already created a service that we are going to use to migrate the database we showed previously. I'm just going to exit out of the screen and go back into the database migration service page. We are just going to use the Rajpo TMS demo 2 service to migrate that database from RDS for MySQL to Azure Database for MySQL. Let's create a new project. You enter a friendly project name and choose the source server type and target server type. In our case, the source server type is RDS for MySQL, and the target server type is Azure Database for MySQL. As you can see, there are several options for you to choose from a migration standpoint for the Azure Database Migration Service. You create and run the activity after choosing the appropriate activity type. Now let's go in and provide the source RDS server details. Provide the username, password. As you can see, DMS uses TLS 1.2 to establish an encrypted connection to your source MySQL database. Once the connection is successful, you will get to provide the target server details as well for the Azure database for MySQL instance you are trying to migrate into. We wanted to keep this very simple, so you provide the target server name, the username, and the password. As long as the connection is successful, you next up get to choose the databases that you want to migrate from the source to the target. Let's move on. As you can see in this view, we've gotten information from regarding all the source databases from that particular source server. We are trying to migrate the classic models database. You see a drop down in the target database for you to change the target database container if need be. You then get into the migration settings view where you configure settings for migrating large object data. You can either go with limited lob size, which is fast and a bulk fetch and apply of all lobs, or unlimited lob size, which is a chunk by chunk fetch of lobs with migration from the source to the target. You save and you move on. You give the activity a name. For the purposes of this demo, I'm just calling it run migration. And done. The migration has started and the activity status changes to running. Let's exit out of this and look at different migration activities. Go into that particular migration activity. You see that this is the run migration that we just created. You can go into the database and you can see that 8 different tables have completed migration. You look at different statistics from an initial load or full load and incremental data sync perspective. So it seems like all the tables are migrating and they are in sync. The target tables are in sync with all of the tables from the source. And if you look at the migration details there, this particular database is ready for cutover. Next up, let's take a look at applying a change in the source and see it replicate live to the target. So we are back to SQL Developer, and we are going to update the classic models.customers. As you can see, for the customer number 103, the phone number ends with 5555. We are updating that to 6666. I'm going to zoom in and show you. So let's run the update. Looks like my database connection reset. Let's run it again. I have auto commit on, so the commit at the end does not matter here, but we've run the update. Let's take a look at what that particular row looks like in Azure Database for MySQL. And there you go. The phone number for customer number 103 has been updated to 6666. and the update logically got replicated from RDS for MySQL to Azure database for MySQL. Now let's go back to the portal and quickly walk you through the cutover experience. You start cutover when the database is ready for cutover. This process will stop all incoming transactions from the source. It will apply all the pending changes in transit, ensure you are safe to point your application to connect to the target. And this is the only downtime you will see when you're trying to migrate using DMS. Once the pending changes are zero and you confirm that there are no writes coming into the source, you click confirm and click apply. And once the cutover process is complete, in this case, you are ready to point your application to the new target database. Now that we've walked through the best practices of migrating your Azure database for MySQL workloads, let's take a look at migrating to Azure database for Postgres. So there are several ways, just like the MySQL, and let's take a look at the migration options, again, spliced across the various migration phases in the CAF framework. Similar to MySQL, you could choose to discover and assess existing Postgres workloads, connect to Azure with your favorite tool, and start migrating your schema from the source to the target. And then you could use a logical replication tool like Azure DMS to provide that codable, repeatable migration. So one of the ways to migrate data, as we called out, and you're going to see this in a demo shortly, is via the logical replication capabilities within the Azure Database Migration Service. This comes with repeatable and scriptable migrations. And in the demo for Postgres to Postgres, we've written some shell scripts to show you how you could use the power of DMS to script the entire migration out in a clickless fashion. And here's how the database migration service works with Postgres. It's very similar to MySQL from a logical replication standpoint. And it is spliced across a couple of stages using logical replication. So basically, what the Azure DMS service does today to migrate your Postgres database from the source to the target Azure DB for Postgres is the fact that before migration starts, it is going to create a logical replication slot uh, with the test decoding plugin that ships with the Postgres community edition. The slot is responsible for storing details of the LSNs for ongoing changes in the source database and using a logical decoder like PG receive logical, for example, you're able to view and peek contents of the slot, get the changes to an intermediate instance, and push those changes in an ACID compliant manner to the target database. In this case, we create a logical replication slot with a test decoding plugin. It starts to collect ongoing changes in the form of LSNs. The slot also helps you notify which LSN to start peeking these changes from. And all of the LSNs, until a program like DMS is able to read from, it is going to just reside in that particular slot, which is why you need to be careful about storage usage because idle slots can continue to collect changes and continue to utilize a lot of storage and possibly enter storage full scenarios. So once the slot is created, the database migration service also does a PG dump of the entire database to a file in the DMS instance and restores the file using a PG restore command. You get to choose the number of jobs that occur in parallel as the migration progresses. So let's say you choose the number of jobs to be 4. The PG dump and PG restore commands will have the ability to migrate 4 tables at once. This means it is going to increase the speed of your migration throughput, but you should also remember the fact that it's going to put more resource usage on the source. And once the target is in full sync with the source, we help you go through the motions of the cutover, just like how you saw with the MySQL demo, and then help you point that application back to the new Azure DB for Postgres instance that you've migrated into, where that's why DMS helps you with that continuous sync and that cutover process of stopping writes from your application to the old source and repointing your application to start working with the new target database is the only downtime you're going to see with this migration option. The Apart from that, we'll move on to the post-migration phase where you remediate apps, tests, and optimize. And this is an ongoing thing to ensure you're able to successfully operate your production workload in Azure Database for Postgres. Let's move on to the next option. This is logical replication. Today, this is supported only for migrations into our flexible server offering. And logical replication is a method of replicating data objects and their changes based upon the replication identity, usually a primary key. Logical replication uses a publish and subscribe model with one or more subscribers subscribing to one or more publications on a publisher node. Subscribers pull data from the publications they subscribe to and may subsequently republish data to allow cascading replication or more complex configurations that you may need to take care of. Logical replication of a table typically starts with taking a snapshot of the data on the publisher database and copying that to the subscriber. Once that is done, the changes on the publisher are sent to the subscriber as they occur in real time. The subscriber applies the data in the same order as the publisher, so transactional consistency is guaranteed for publications, just like DMS, within a single subscription. This method of data replication is sometimes referred to as transactional replication as well in the SQL Server world. Last but not the least, dump and restore one-time loads, easy, fast migrations. PG dump today is single-threaded, but it has proved to work well, which is one of the reasons why we use it in the database migration service as well. It can be run via command line or even via the PG admin utility. And the jobs parameter we talked about for the Azure database migration service also applies to the PG dump and PG restore commands also. But one interesting thing I'd like to note here is the use of Azure Data Factory as well. As we spoke about this in the MySQL section, you're able to ingest all data with built-in connectors. It's easy to use, cost-effective, and can provide very good throughput. In fact, over the past few months, we went in and improved the copy activity for copying data into Azure DB for Postgres. And we've been able to parallelize it and ensure we get about 5 times better throughput than earlier with the recent changes, where you go in and opt for parallel chunking and parallel copy into Azure Database for Postgres with the right parameters in place. Similar to MySQL, there we've documented all of the best practices to prepare your target. You could increase queue, increase disk for IOPS for fast migrations, disable indexes and recreate them later, enabling you to perform super fast offline migrations with whatever tool you choose to use. So in short, there are 3 different options for you to migrate into Azure DB for Postgres, namely Azure Database Migration Service and Logical Replication for online migrations, and various dump and restore options, including the Azure Data Factory capability to be able to help you do offline migrations in a fast manner, thereby enabling you to move into Azure DB for Postgres as soon as possible. Next up, let's take a look at a demo of a migration from Postgres to Azure DB for Postgres. We've done something a bit differently here. We are using the Azure Database Migration Service, but we wanted to show you the power of using Azure, the DMS service via CLI. We have written some shell scripts. We have demoed a clickless migration from a Postgres database to Azure DB for Postgres. Let's take a look.
Now let's look at how a powerful service like DMS can enable clickless migrations. I'm going to do a migration from Postgres to Azure database for Postgres, we've written some shell scripts that use the DMS CLI to automate the entire migration activity. As you can see, this is the project. You could just fork it from a GitHub repository. Let's look at the DMS setup shell script. This gets inputs for the DMS service and creates the service for use. It takes in all of the properties required to set up the service and will take about 12 to 20 minutes to finish. Next up, let's take a look at the source database details. As you can see, the password field is empty. In the interest of better security, we are going to take it at runtime. This is the target we are going to migrate into, and that is the database, the sportsdb_sample. Here's an options JSON in case you wanted to move it to another database in the target. You could use it via the options. Now let's go back to the Azure portal. For the purposes of this demo, we've already set up a DMS service. It's called rthiaga-bash. Given it takes time to set this up, we are just going to use an existing DMS service to run the migration activity and move data from the database you saw in the source to the database you saw in the target JSON configuration file. Let's run the activity shell script. Once you run it, you're given the location where you would like to run the DMS activity. You're given the resource group name. Next up, the service name of the DMS service that you created. In this case, we are going to use the existing one. The project name next up, we'll just name it based off of the database that we are trying to migrate, which is SportsDB in this case. Then within a project, you create a migration task. This shell script is going to automate all of the heavy lifting. It's going to create all of the required artifacts for the migration. And as you can see, we are creating the activity in that particular subscription that we are trying to migrate into for Azure database for Postgres. Everything has succeeded, and we are giving the source database password at runtime in the interest of better security. Same goes with the target database, and once that is entered, all of the activity and the artifacts are created behind, and the data migration is queued for execution. Let's go back to the portal now. As the migration is already running, the portal, when you refresh it, it is going to show you the status of the migration. As you can see, it's the same migration project we created. You click into it and you will see the migration activity we created to migrate the sportsdb_sample database. It's an online migration activity. It's already running and it is ready for cutover. So the migration completed, given it was a pretty small database, it ran in 26 seconds and it moved over 107 tables from that particular source to target. So when you're ready, you could cut over and point your application to the new target that all of this data has migrated into after you perform all of the cutover activities. This is an example of how you could just use a service like DMS to run multiple migrations and make these migrations as repeatable as possible.
Now that we've walked you through homogeneous migrations, namely migrations from MySQL to Azure DB for MySQL or Postgres to Azure DB for Postgres, let's get into the landscape of heterogeneous migrations. The top heterogeneous migration pair we see into the open source databases within the Azure portfolio today is Oracle to Postgres migration. So let's take a look at the migration journey map. Like homogeneous migration, Oracle to Postgres migrations also need to follow through a process, but the process is a bit different and a little bit more involved when it comes to the initial stages of evaluation and discovery to the cutover and operate phase. As Sunil covered previously, there are several reasons why customers want to do these migrations today, even though these are hard multi step projects to pull off. We are working very hard to add as much predictability as possible via people, process, and tools into these type of migrations. Let's dive into the migration journey map first. We'll then walk you through the process, how it looks like from a pre-migration, migration, and post-migration process. We'll walk you through what tools we currently have in the Azure ecosystem to help you navigate these hard multi-step heterogeneous migrations, and then walk you through an exciting guide we've been working on, which is very detailed, and we'll also show you a quick demo of the guide and also best practices on how we believe you should be using this guide to navigate this hard landscape of migrating from Oracle to Postgres. From a process standpoint, it is similar to how we start off from preparing for a homogeneous migration by itself. You go in, evaluate the need for a migration. You discover all of your Oracle workloads that you'd like to migrate from one place to, or your on-premises environments, Azure VMs, or even other clouds to Azure DB for Postgres. There are tools available out there, even as part of the Azure Migrate ecosystem, for you to go in and discover all of your Oracle workloads in one place. And then you look at the viability of changing your underlying engine. Like, you could have various reasons why you would want to do that, but there are several tools available out there, including open source tools like Auto2PG, that we have guides for, and we have scripted them out in a way to make it very easy for you to run in a Windows server or even Linux server. You point it to your database and you start assessing and planning the migration. These tools go through all of the Oracle objects available in your Oracle workload. These include database storage objects like tables, constraints, indexes, etc., and database code objects that include triggers, functions, stored procedures. Look through each and every line and try to see what the automated conversion percentage looks like, and how all of these features that you have been using in Oracle will work in Postgres. Not just for the database, you will also need to ensure your front end applications are also converted to be able to work with Postgres. There are tools available out there that we can recommend that can, in case you're not using an ORM layer like Hibernate that automatically translates your application queries between multiple database engines. There are ways to parse through embedded SQL in your application code and convert them to Postgres, so that you can start evaluating Postgres and do the conversion, validate and test the conversion, and move along with the migration. So the assess and plan stages is one of the most important stages in the migration. It looks at the viability of your migrations, make sure you're set up for success, and ensures your workload can run well in Postgres with minimal changes, or with changes that might require some sort of re-architecture. So once your planning is complete and you are convinced that your workload can run in Postgres, you go in and do the conversion aspect. There are multiple facets to the conversion. Not only are you going to look for features within the Postgres ecosystem to use for corresponding Oracle features, but you're also going to need to emulate a few things. For example, advanced queues or Oracle DB mail. These features don't have a one-on-one hit or combination in the Postgres world, and that's where the power of cloud comes into picture. You get to use other services within the cloud to ensure all of the current functionality that you're using in your Oracle database are emulated as fast as possible, functionally correct, and perform well as expected. Once the conversion phase is complete, which is going to be a combination of tools and manual effort required by people, depending on the number of features or the type of features you're using in your Oracle workload, you move on to validating and testing your conversion first. You need to do a sample data migration, try to run all of your Oracle objects, evaluate your Oracle objects, test them, and make sure the conversion is fine. Ensure parts of your application are working as expected in the Postgres ecosystem and ensure all of the objects are created in Postgres without any issues. You then move on to the migration phase where you move data from a source to a target. Here's where we have tools like Aura2PG again that can perform fast one-time migrations, or Azure Database Migration Service, which is currently in preview for the Oracle to Postgres scenario that takes care of online migrations, just like how we saw for the MySQL to MySQL use case and Postgres to Postgres use case. If you're migrating hundreds and thousands of workloads like some of our customers, we also have partners in this space, like the Microsoft Consulting Services or other partners we'd be happy to put you in touch with in order for you to navigate this multi-step process as quickly as possible, keeping in mind all of the important best practices to take care of. Once the migration is done, you go through the same validate data and testing full stack capabilities. You need to ensure with appropriate data, all of your functionality for that particular workload meets the mission and vision of your workload and application. And once you're ready and you ensure all of the support is in place, your personnel, they are well versed with the Postgres ecosystem and the Azure ecosystem, that's when you're ready to cut over and operate your workload in Postgres. We recommend taking a look at the database migration guide that is going to come up real quick in terms of navigating this Oracle to Postgres migration scenario. We'll also walk you through a detailed migration guide that we've been working on from an Oracle feature to Postgres feature mapping perspective that is going to add more predictability to this multi-step process. Moving on, what does this migration process look like compared to the CAF framework? We've been talking about the CAF framework where we talked about three different phases in a migration, namely pre-migration, data migration, and the post-migration phase. Now, mapping the journey map back to the CAF framework, anything from discover, where evaluation, assessments, and plans to ensure you believe your workload is going to work in Postgres, your Oracle workload is going to work in Postgres, to the conversion and test conversion phase fall as part of the pre-migration phase of the CAF framework for Oracle to Postgres migrations. We believe customers will spend about 60% of the entire migration project in pre-migration phase, given the importance of this multi-step process and the level of work and dive deep that goes into the pre-migration phase, specifically for the Oracle to Postgres migrations. Then you move into the data migration phase, where you set up the migration infrastructure, whatever tool you use. Let's take a look at the example of using Azure DMS to perform near zero downtime migrations. You set up the migration infrastructure, set up migration, replicate ongoing changes, and then move on to the cutover and test. Let's take a look at how this works. Let's imagine you have an application workload running with Oracle, and the application is connecting to Oracle. You set up the Azure DMS service and you create a migration activity, to set up the migration activity to start migrating data into the post Azure DB for Postgres instance. And that increase in the database size depicts that initial bulk load or the initial load of the migration. And once the initial load is done, Azure services like Azure DMS have the capability to look for ongoing changes in the underlying redo logs in Oracle, collect those changes, translate them into Postgres parlance, and apply them in the same order they occurred on the source. And this is where you get to keep your target Postgres instance in full sync with the source as you test your application workload out, or maybe even convert to a certain point in case you have missed out on a few conversions. And then once you're ready and everyone, all of the testing artifacts are taken care of, you've optimized for the running of this particular workload in your Postgres ecosystem, you're ready to switch over the app to connect to the target Postgres instance. And as always, the post migration phase is where you ensure everything is going to work as expected. You run functional and performance tests. You iteratively make sure everything looks good from a workload point of view. make sure your customers are going to get the same exact awesome experience that they were getting with your Oracle database. Uh, Based on the test you perform, you address any performance issues, then retest to confirm the improvements have taken effect. You remediate these applications and ensure once everything falls in line is when your application is ready to run in Postgres. All of these steps in a detailed manner are from starting of the pre-migration phase to the optimize, cutover, and operate phase are given in our database migration guide linked below on the screen here. It is also very easy to remember this URL. It is just aka.ms/data migration, and not just for Oracle to Postgres migrations, but advice and guidance on all types of migrations into the Azure data platform are given in this particular database migration guide. What else did we do? We created an Oracle to Postgres conversion guide. It has all of the conversion best practices in one place. We wrote 300 plus pages based off of our experience working with various customers. And as you can see on the screen here, these type of migrations are truly solved via a combination of people, process, and technology. And of those pieces, we took all of the best practices and put it in one guide here. And as you can see on the from the example there, we not only went with detailing the general compatibility level of each feature from Oracle and Postgres, we also gave you a quick overview of the automation capability, the summary of the differences, and other important things from a comparison standpoint to help make this process as easy and predictable as possible. Let's take a look at how this guide looks like and what the best practices are from using this guide for navigating this tough landscape of migrating your Oracle workloads to Postgres. This is a copy of the migration guide. Let's go take a look. We've not only walked you through the introduction and concepts of a migration, such as best practices to set up Oracle PG, among other tools to navigate this migration landscape. We also walk you through different features in Oracle with code snippets and best practices of using those features in Oracle, plus what those corresponding conversion mappings look like for each of these features in Postgres. As you navigate through this linkable index section, we introduce you to the migration guide summary table. In this table, for each and every Oracle database feature, we walk you through the corresponding Azure database for Postgres feature, which we believe is the best practice to convert to. We also walk you through the overall compatibility or migration complexity of that feature and how that feature sits in Postgres, along with the Oracle PG automation level as applicable. We then top it off with the top considerations for that feature and how that particular feature is supposed to work in Postgres. Even the migration guide summary table is linkable. Let's say you wanted to learn more about backup and recovery practices, best practices in Postgres. You could directly go into the chapter. It walks you through the differences summary and also different kinds of RMAN backups with code examples. Same with data pump before walking you through the best practices of using backup and restore in Azure database for Postgres. Lastly, we also walk you through a table which clearly tells you the differences between each and every sub feature when it compares to backup and recovery in Oracle compared to Postgres. Once you're done, as we called it, this is a linkable section. You could go back to the main summary table and start looking at various other aspects of the migration as you deem fit in terms of the migration project by itself. Let's dive into another example. Let's pick a very database oriented feature for understanding various details about this. For example, constraints. As you know, Oracle and PostgreSQL are relational databases that support constraints, but they don't work the same. So in this section, we walk you through the different types of constraints and how each of these constraints fit in the Postgres landscape. We then dive deeper into examples, code snippets about the differences between each of these constraints and what they navigate in terms of the usage by itself. And then we walk you through a comparison table to clearly tell you what is supported and what is not supported to give you a good view into how you would go about re-architecting a few of these constraints that are not supported in Postgres. Last but not the least, we also link the appropriate documentation links for both Oracle and Postgres and walk you through the differences between Postgres 11, 12, and 13, making the decision of going to the right version of Postgres as a target as simple as possible for you. Thank you. With that, it brings us to the end of this presentation. Thank you for being a great audience and listening to us about different ways to migrate your workloads into Azure open source databases, be it homogeneous migrations or heterogeneous migrations. This slide gives you an overview of some easy to use important links for you to understand more details about our platform as a service offerings for MySQL and Postgres. We've included a couple of customer stories as well, which we believe is very interesting. And last but not the least, if you have questions, feedback about this presentation, or you want to talk to us about migrations in general, feel free to reach out to us in those via those ask aliases at the bottom of the screen. Once again, thank you for the time you spent attending this presentation. We'd now be very happy to take any questions that you may have. Thank you very much once again. Thank you.